All right, writing linear equations. Let's get started. So first of all, I want you to think about a little bit, and I'll kind of guide you through it here. But what is a linear equation, and why do we end up using lines to represent them? So let's think about this. We started off. We've talked about like what this means, right? X equals 4, for example. All right, it's like, well, what value for x makes this true? Well, 4, right? 4 equals 4. So how do you represent that visually? Well, you can use a number line, right? You put 0 on there, you put 4 on there, and there's 4, okay? Boring visualization, but that's how you would visualize the solution to this equation, just 4. How about this? X less than 4. Okay, well, there's lots of numbers that you could plug in for x that are less than 4. 1, 0, negative 12, negative pi. Lots of them, right? So how do you represent that? Well, you draw your number line. Again, we'll put 0 on there just for reference, and we'll put 4 on there, and then we have an open dot at 4, and then we shade everything to the left. That's how we visually represent x less than 4. What if I had something like this? Let me get rid of the, well, I can see them for now. All right, so what if I had something like this? Y equals 2x. How would I visualize the solutions to that? In other words, how would I, that's exactly what I mean. How would I visualize the solutions to this? In other words, what values for x and y make this true, and how can we visualize it? Well, you might think, 0 makes that a true statement, right? 0 times 2 is 0, which is 0. You might be like, well, what if I put in 1 for x? Well, 1 will give you, if you plug in 1, you'll get 2 for y. So that satisfies the equation. And you can keep going like this, and what you'll find is that you end up with a line. All of these points will fall on the same line. Okay, so this is an equation that we call a linear equation, because to represent it, you need a line. And we can't just use a number line like we did up here. So up here we could use a number line, but that won't work for this because we have both an x and a y. So we'll take the number line that's horizontal and we'll use it, but we also need another number line. We need a vertical number line, the y-axis. Okay, so that's why we use an x-y axis in so many situations, because we have to relate two variables. We have to relate x and y. All right, so what else did I want to write here? I want to write one more thing. So a linear equation is an equation whose solutions, I know it's a weird way to write solutions, but whose solutions are represented, that says represented, by a line. Okay? So, let's talk about what's the general basic form of an equation of the line. This is a specific line, y equals 2x, but what do all lines look like at their basic level? Well, let's draw just an arbitrary random line on the x-axis. Let's go, let's change colors here. So let's just put a point here, and that'll be the y-intercept, and we'll call that point 0, b. Okay, and then we'll take any other point on the xy plane. It doesn't matter which one it is. Okay, and we'll call that xy. Okay, so 2 points create a line. I just picked the y-intercept because every line will intersect the y-axis at least one spot, or only one spot, and then any other point on that line. We take those two things together. We already know some things about lines. They have a slope. They have their rate of change. Their steepness is called the slope, and we have an equation for that. So let's use that equation with our given points here and see if we can't find a general equation of a line. I'm going to erase this to make some space here. Okay, so we know that the slope equation in this example would give us y minus b divided by x minus 0. Well, what if we times both sides by x? Then I get this, mx is equal to y minus b. I'm going to add b to both sides, and ultimately what I get is this, y equals mx plus b. Now I could have just given that to you, but we're in Algebra 2 now, so I feel like you need to kind of see where some of these equations come from. But this is the basic equation of a line, right? And so where m is the slope, b is the y-intercept. Let's see if we can apply that in some of these examples. Okay? So over here, I want to write the equation of the line that's given to me. Now, if I know that if I have the y-intercept and if I have the slope, I can write the equation for it. So first, I said, here's an equation. How could we represent it visually? Now I'm saying, here's the representation of it visually. What equation is being represented by this line? All right, so you look at this and you see that the y-intercept here at 0, -2, that's our b. And then we can figure out the slope. My favorite way to figure out the slope is just to count. So we start at this point, and maybe we go over to this point. So we go up 1, and then over to, up 1 and left 4. How about that? So up 1, left 4. So we can write our equation then. Y equals m, which is -1/4, up 1, left 4, times x, plus the y-intercept. It's plus a -2, so we'll just write -2. Okay, so there's my equation of the line. Y equals -1/4 x minus 2. How about this one? What if I just give you the slope and a point? So we want to write the equation of the line that passes through 0, 4 and has a slope of 4/3. You might want to try this one, see how you do. This is not just any point that we've been given. We've been given 0, 4. 0, 4 is the y-intercept. It's a very special point, okay? So this actually gives us our b value then. This is m. And so if we want to write our equation of the line then, it will just look like this. Y equals 4/3 x plus 4. And that's our equation of the line that we could represent on the graph of the xy plane if we wanted to. One more thing about this, when you get your slopes, and even your y-intercepts too, but especially your slopes, if they're fractions, you want to leave them as fractions, because fractions are really useful for slope, because as you've already seen, you can do rise over run, and if it's in fraction form, it's really convenient. Okay, now, y equals mx plus b is the most fundamental form of an equation of a line, okay? But you're not always given the y-intercept. Sometimes you're just given a point, or sometimes you're given 2 points, and you have to find the equation of the line, right? To do that, my favorite way is point-slope form. There's other ways that you can do it, and ask me to show you those if you don't like point-slope form, but point-slope form is really useful. Let me show you why. I'll show you where it comes from as well. So if we take our slope formula, and instead of y1 and y2, I'm just going to take y minus y1 and x minus x1. Okay, so this is if we have a slope, which is m, and a point x1, y1. Okay, so if I've got that, then this is what my slope formula looks like. All right, and I'm going to times both sides by x minus x1, so I'll get this. M times x minus x1 is equal to y minus y1. And then I'm going to add y1 to both sides. And I'll end up with this. Y equals m times x minus x1 plus y1. Now, if you found the beginning of that confusing, that's fine. You might want to rewind it and watch it again. But this is the big important takeaway. This is point slope form right here. Okay, this is going to be super useful this trimester, this year, whatever. So that you want to have circled on your notes. If you write down nothing from that box, let it be that. All right, so let's get rid of this yellow circle here. And we're going to use this a few times. Okay, so find the equation of the line that passes through the point, 6, -2, and has a slope of -4. Well, guess what? We have a point, and we have the slope. So we can use point-slope form. So this is our m, this is our point, this is our x1 and our y1. So I can use point-slope form to find the equation of this line. So it would be y equals -4. By the way, you should try this. Go ahead and pause it and try it. -4 times x minus 6 plus a -2. That's just -2. Okay, so this is y equals, and by the way, you should always simplify to slope-intercept form. Y equals mx plus b form. Okay, so this would be y equals -4x. -4 times -6 is 24. -2. Last thing, 24 minus 2, that is equal to 22. Okay? Next one. Find the equation of the line if you're given 2 points. So if we're given 2 points, I want to use point slope form. It's my favorite way to find the equation of a line. But if I have 2 points, I need the slope first. So I'll go find the slope first. So m is going to be 6 minus 3 divided by 3 minus a negative 4. Nope, try again. Sorry, 6 minus 3, negative 4 minus 2. And when you simplify that, you will get down to m equals 2. Nope, negative 1/2, sorry, negative 1/2. So there's my slope. And then I just need a point. Well, I can use whatever point I want. I'll take the one with the positive numbers. So this will be y equals negative 1/2 times x minus 2 plus 3. So there's point slope form. Let's simplify that so that it's in its most simplified form, which is slope intercept form. So this would be y equals, when I distribute the negative 1/2, negative 1/2 x plus 1 plus 3. 1 plus 3 is 4. Negative 1/2 x plus 4. Okay, so there's the equation of that line. Next one, you should try. I'm going to speed up the video. I'll work through it here, but I'm going to speed up the video so I won't bore you with me talking about it, and then see how you do. What I like about this problem is that you get a slope of 0, and so that might be confusing. Like, what does that mean? It means it's a horizontal line, but maybe you don't catch that right away. So you go to point slope form, you drop everything in there, m, x1, y1, and simplify it, and you get down to your answer. So even if you don't realize it's a horizontal line at first, you can get there from using point slope form. That's one of the things, that's what I love so much about point slope form, is it works in so many different situations. So let's go down here. Numbers 6 and 7 ask you to draw or find the equations of lines that are perpendicular or parallel to other lines. All right, so let's explore that for a little bit here. In this number 6, we want to write the equation of and sketch the line that is parallel to this given line and through 0, 5. So if we want a line, we need 2 things. We need a point and the slope. Okay, I have a point. I already have it. It's right here. It's given to me. Okay, it's 0, 5. I'll even put it on the graph. I need to know what the slope is. If I get that, then I can get the equation of the line. Let me give you a picture of what this line should look like first here. So it's going to look something like this. Okay. In fact, if we know the slope, because remember, parallel lines never intersect. Okay, so if we know the slope of this line, then we can get the, not only can we get a sketch, we can get the exact line. So this goes through 1, 1, and then I'll pick another point here. How about this one? So we'll go up 1, 2, 3, 4, and over 1, 2. So we've got a slope of 4 over 2, which is 2. So let's write that down. M equals 4 over 2, which equals 2. And then we have, so there's our slope, and then we have a point is 0, 5. So we can just write y equals 2 times x minus 0 plus 5. And actually, it's not just any point, it's the y-intercept, isn't it? So it would just be 2x plus 5. I didn't even need point slope form on that one. Okay, so there's my equation of the line. And now I want to write the equation of and sketch the line that is perpendicular to y equals negative 1/3 x minus 4. So the last one here, we're thinking about perpendicular lines. So let's sketch this first line here. So negative 4. And then the slope is negative 1/3. So we'll go down 1 and over 3. So here is what my line looks like. The given line. The line that we want is perpendicular to this line. And it goes through the point 0, 2. So here's the point 0, 2. It's got to be perpendicular. Perpendicular means they cross at a 90-degree angle. Okay, so that line will look something like that, so that they form a 90-degree angle. We need to know what the slope of the red line is, the perpendicular one, because we already know a point. So the point is just going to be 0, 2. It goes through 0, 2. And we know the y-intercept too. So it's the same thing. We need to know what the slope is. Perpendicular lines have slopes that are opposite reciprocals. That means you flip the fraction and change the sign on the fraction for the slope. So if the slope here in blue is m equals 1/3, negative 1/3, then the slope in red must be, see, opposite reciprocal. So opposite sign must make it positive. Reciprocal flips it, which makes it 3/1, which is just 3. Since I know what the y-intercept is 2, I can just write the equation of the line. 3x plus 2. Okay, so there's the equation of the line that's perpendicular to it. Okay, so remember, if you want a line, you need a point and the slope. If you want a perpendicular line, you just need to figure out what point it's going through and the opposite reciprocal of the line that you're given. If you want a parallel line, find your point, figure out the slope of the given line, and that's the slope of your new line. And that's it for now on writing linear equations.